Hello, everybody. Welcome to today's lesson, which is subtopic 3.8, Solution to Trigonometric Equations over a Finite Interval, Analytically and Graphically. This is the first part of maybe 2 or 3 parts, at most 3 parts. Okay, so let's get started, guys. By the way, in the second part or the third part, you're going to understand what I mean by this phrase, over a finite interval. In the meantime, don't get too upset by this phrase, okay? And remember, what we mean by analytically, what we mean is basically without the use of technology, without any approximation methods. Or you may think of this as with pencil and paper in your brain, that's it. And graphically is through the use of software or calculators. Okay, so the first part is completely about the analytical way to solve trigonometric equations. We will be solving equations that look like this. Take a look at this. Sine of 2x equals 1, 2 times the cosine of this, 3x minus 1, being equal to 0. Look at these ones. Just take a look at the type of equations that we're going to be solving in this subtopic. All right. So by the end of this subtopic, you should be able to do this and many more. Okay, now let me tell you of a reminder. By now, we know how to calculate the trigonometric functions of special angles. What angles? 0 degrees, 30, 45, 60, 90 degrees, and all their multiples, okay, through the use of special triangles. And we've been doing this quite a lot. This was actually a problem in the last exam. So you know that by constructing these special triangles, this equilateral triangle of side 2, we can get the trigonometric functions of 30 degrees, which is this angle in here, and the trigonometric functions of 60 degrees, which is the angle in here. Okay, we can do this just with pencil and paper, analytically. We don't need any calculator to do this. And with the usage of this other special triangle, an isosceles triangle of side 1 and 1, and with angles of 45 degrees, then we can get the trigonometric functions of 45 degrees. Now, what about 0 and 90 degrees? Those are extremely simple, right? You should know by now rather quickly that the sine of 0 degrees is 0, the sine of 90 degrees is 1, okay? The cosine of 0 degrees is 1, and that the cosine of 90 degrees is equal to 0. This also should be rather, these ones should be memorized actually. This is extremely simple. These other 3 rectangles are not that simple to memorize, but don't worry because you can always get them with these special triangles, and it takes you about half a minute, right? Okay, so let me make a little stop here. So I was saying, guys, that okay, so we could calculate trigonometric functions for some special angles, and I made a list in here. Now, if you notice, I wrote the angles, which are these things in between parentheses. I wrote them in radians. Why? Because I want you to be aware. We're gonna use radians all throughout this topic. So instead of writing this, sine of 30 degrees equals 1/2, we're gonna write the following: sine of pi over 6 radians equals 1/2. Remember that 30 degrees is equal to pi over 6 radians, okay? So instead of using these statements for the trigonometric functions of the angle of 30 degrees, we're gonna use the same statements for the same angle, but written in radians, okay, which is pi over 6. Pi over 6 radians is equal to 30 degrees. So if you don't remember, I told you to that you should try to memorize those special angles. Okay, look at this whole figure. Remember that pi radians, I hope you can see, this was the best image I could find. Pi radians is equal to 180 degrees, which is basically half a turn. It's an angle of 180 degrees. That's going to be equal to pi radians. And for the angles in between 0 and 180 degrees, you can get the equivalence in radians by just taking fractions, right? For example, the angle of 90 degrees, since it's half of this angle, well, then if this angle in radians is pi, then half of that angle, which is 90, will be pi over 2. It's that simple, guys. You need to understand that graphically or visually. What about 60 degrees? 60 degrees is 1/3 of 180 degrees. It's just 1/3 of half a turn. And so if 180 degrees is pi, then 60 degrees will be pi over 3, because 60 degrees is the third part of 180 degrees. And the same for the angle of 45 degrees, which is pi over 4, and for the angle of 30 degrees, which is pi over 6. You need to memorize this, and clearly 0 radians is equal to 0 degrees. These 5 are very important to have present at all times. We're going to use them a lot. So I have the list in here, like I said. Okay, sine of 0 radians is equal to 0, and etc. for the other angles. This is 30 degrees, this is 45 degrees, 60 degrees, and 90 degrees. And these are obtained through the special triangles. Now, I want you to look at something, guys, in here, kind of like a pattern, in order to memorize these special values. Can you notice the following? We go from 0 degrees to 90 degrees, or from 0 radians to pi over 2 radians, increasingly, like we have 0, and then pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, and pi over 2, which is 90 degrees. So we go increasingly. And look at the values of the functions. We go from 0 to 1, but look at this. We have 0, and then 1 over 2, and then the square root of 2 over 2, and then the square root of 3 over 2, and then 1. So if you wrote the square root in here for 1, you can see the pattern. Can you see? It's the square root of 1 over 2, and then the square root of 2 over 2, and then the square root of 3 over 2. So that makes a nice pattern for you to memorize. Obviously, we never write the square root over 1 because it's going to be the same, but you can see the pattern, right? For sine. And for cosine, it goes backwards. The pattern goes in this direction, from bottom to top. Can you see? 0, 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and then 1. And for the tangent, all you have to do basically is, since you remember the tangent can be, well, is defined. The tangent of any angle theta is defined as sine of theta over cosine of theta. Then basically all you have to do to get the tangent of all of these angles is dividing the respective sine over the cosine. Tangent of 0 is nothing but sine of 0 over cosine of 0. You're going to get 0. Tangent of pi over 6 is nothing but sine of pi over 6, which is this much, over cosine of pi over 6, which is this much. When you divide this number over this number, you're going to get this, etc., etc. Now, why do I say the tangent of pi over 2 does not exist? Because according to this same property or definition, we should have that the tangent of pi over 2 radians is equal to the sine of pi over 2 radians over the cosine of pi over 2, and that creates a problem. Sine of pi over 2 is equal to 1. That's good. But the problem is that cosine of pi over 2 is equal to 0. And we encounter a division over 0, which cannot be computed. And therefore, we cannot calculate the tangent of pi over 2. That value does not exist. Okay. All right. So we have all the ingredients, guys, to start solving our equations. Once again, I'm gonna make a little pause. I'm gonna leave this list in here. I recommend that I think it's a good idea to memorize these things. And if you don't want to memorize them, at least have them written down or have them handy. Okay, like have them ready to visualize them. Okay, let's make again another pause, and then we're gonna go over 3 or 4 examples of solution of equations, trigonometric equations, using all of this information. So let's get started, guys, with the resolution of these equations, the following examples. You're gonna see how easy it is at first. So let's do it. So let's solve this equation. We have the sine of 3x equals 1. All right, so we want to solve this equation. For what value of x in radians should we have that the sine of 3 times that value is equal to 1? How do we solve this type of equation? With pencil and paper. Okay, what we do is this, guys. We try to go to this list of, I repeat, the trigonometric functions of special angles, which are the only types of angles that we can get the trigonometric functions for manually. And we try to see if there is a particular angle for which the sine of that angle is equal to 1. If we investigate this part of the list, we find that the sine of pi over 2 radians is equal to 1. You see? Look at this. The sine of this angle in here, because this is an angle, right? This thing is an angle, is equal to 1. And we have that the sine of pi over 2 is equal to 1. We know this beforehand. So what can we deduce? We can deduce that then 3x must be equal to pi over 2. You see? Because if 3x is equal to pi over 2, we get 1 according to this. Okay, fine. So now let's continue. All we need to do, if you look at this, we have let's call it a simple equation, a linear equation, and all you need to do is isolate the variable x. So let's divide over 3 in both sides, and we will get pi over 6. Pi over 6. That's it. That's it. Of course, I'm starting very simply just to give you an idea of how this works. So this is the solution for this particular equation. Example B. Let's look at the cosine of 2x minus 1 being equal to 0. How do we solve this equation? Cosine of 2x minus 1 equals 0. I go to my list, I look at the part of the cosines, and then I ask myself, is there an angle for which the cosine of that angle equals 0? Okay, it's this one. It's again pi over 2. Cosine of pi over 2 equals 0. So then we can deduce that whatever angle this is, well, no, that this angle should be the same as pi over 2. And then I just continue solving this equation. 2x equals pi over 2 plus 1. And finally, x equals pi over 2 plus 1 over 2. We just divide both sides over 2. We leave it like as it is. We don't have to simplify anything further. Okay, this is a perfect solution. You can leave it just like that. I mean, yeah, you can add pi over 2 plus 1, but you can keep it this way. This is a perfectly good answer. Okay, so you see it's rather simple, guys. For the moment, I always try to scare you that way. Okay, example C. We have 2 times the sine of 1 minus 3x equals 1. Okay, so now what do we do first? We don't go look for like in the way we did this before. Like we always try to see, okay, sine of this equals to 1, then I'm looking for the 1 in here, and therefore I can realize that this angle should be pi over 2. No, we need to do something first in here, in this one, because this one is a little different. Why? Because the sine function is being multiplied by a constant 2, which did not occur in here nor here. In this one, we only have sine of an angle equals a value. Cosine of an angle equals a value. We never had the functions, the trigonometric functions, being multiplied by any constant, which we do have in here. This is multiplied by 2. So the first thing for you to do always when you try to solve a trigonometric equation, well, in most cases, the most effective way to do this is by first doing some simplification. And what I mean by that is try to get your equation to look like something like this. Sine of something equals some value, or cosine of something equals some value, or tangent of something equals some value. Try this first. This is the first approach you should employ. So with that in mind, let's do that. What can we do? In order to have this thing I told you, we divide over 2, right? In order to get rid of this factor in here. So we're going to have this. Sine of 1 minus 3x equals 1 over 2. That's what I mean. Sine of some angle equals some value. And now we go to the list. Is there an angle for which the sine of such angle is equal to 1/2? There it is. Sine of pi over 6 radians equals 1/2. Therefore, I can make the deduction that this should be equal to pi over 6. And that's what I write. 1 minus 3x equals pi over 6. Okay? And then I just continue solving this equation. And now that you have done this, the rest is quite simple. We get 1 minus pi over 6 equals 3x. Make sure what I did. Okay. And then we just divide both sides over 3. 1 minus pi over 6 over 3 equals x. That's it, guys. It's that simple. Another example. D. We have 2 times the cosine of 3x plus 2 minus the square root of 2 equals 0. Okay, you can make a pause right here and try to solve this one on your own. Make a pause. Pause the video, try to solve this one, and then come back to the video. Okay, so this one, I'm gonna do the same thing I told you before. I'm gonna try to simplify this so that I can get cosine of something equals a value. That's very simple. All we need to do is this. The algebra is quite simple. We add the square root of 2 on both sides, and then we divide over 2. Okay, and now we have this form. The function of an angle equals a value in this way. Okay, so for what angle do we have that the cosine of such angle is equal to this? Square root of 2 over 2. So let's see. It's going to be pi over 4. So this value, all of this should be equal to pi over 4. So let's make that statement. we can know that 3x plus 2 equals pi over 4 radians, and then the rest is a piece of cake. So pi over 4 minus 2, and finally x equals pi over 4 minus 2 over 3. That's it. Okay, perfect. And one more. Exercise E. We have the tangent of, well, let me write brackets. Tangent of 2 times x minus 3 plus 1 minus 1 equals 0. All right, so let's see. Same idea. Try to reduce the complexity of this by oh no, I forgot there's something here over the square root of 3. So try to get, let me write it correctly. We have tangent of this over the square root of 3 minus 1 equals 0. This is the equation. Okay, so try to reduce this to something like tangent of a value, tangent of an angle equals a value. Same idea. Try to stop the video, pause it, and then come back and compare your solution with mine. So I'm gonna do it. So what can I do first? I can add 1. I can put this to the other side. So it's gonna look like this. Okay. Then I can multiply by the square root of 3. Both sides. And that's it. Now I have that form. Tangent of some angle, which is all of this. That's why I wrote brackets. Being equal to the square root of 3. Okay, so I go to the part of the tangent, and I realize that the tangent of pi over 3 equals the square root of 3. So all of this thing inside the brackets should be equal to pi over 3, and that's the deduction I can do. So 2 times x minus 3 plus 1 equals pi over 3, and from then on it's the same idea. You just isolate your variable x, which I'm not gonna do. Okay, it's very simple, and that's how it works, guys. You see, let me go there with you for questions, and that will be the first part of how to solve trigonometric equations for well, analytically. When we can do that, we cannot always do this type of thing because we are relying on this list. Okay, for example, if we, let me do this in blue, if we had this type of equation, for example, let's suppose sine of 2x equals let's say 1/5. Okay, we cannot do this analytically or exactly, at least not easily, not in this way, because we don't have any angle for which the sine of such angle is 1/5 if you look at this table, right? So we don't know, at this point we don't know how to do this analytically. And in college, some of you may see this later, but it's actually quite tricky and it's not really encouraged. Okay, for this type of equations, that's when we use the graphical approach. So that's it, guys. Thank you.